Today we have Sebastiaan here talking to us. He is in the Netherlands, and he's going to be talking about implementing data and databases on Kubernetes within the Dutch government, which, to be honest, sounds really interesting. So I'm excited for this. I'll hand over to Sebastiaan, and thank you.
So this is a presentation that I did in April in Amsterdam during KubeCon as well. I haven't changed anything for it. I just wanted to have it now, but I will update as we go through the slides. By talking to it. This is a presentation about running databases and Kubernetes within the Dutch government. Let's get it going. So there's going to be a short introduction. Who am I? Then I'm going to talk to a challenge that we had, which is called, basically the challenge that we have is called to break the glass. I will talk to it in just a little bit. We did some tests on database performance on Ceph on premise, which might be interesting as well. And also we have some technical, we're going into the depth of how databases work on that subject as well. So that's going to be cool. There is some information about some other challenges and ideas that we've run into. I'm just sprawling them out. I can update you on where we are on that as well, because there are some updates there. I end with general recommendations. So like if you want to introduce data on Kubernetes in your organization, how should you approach it? And I end up with some conclusions and takeaways. Let's first talk about who am I? So I'm Sebastiaan Mannem. Currently I am only working for my own company, which is called Mannem Solutions, which is a one-man stop shop, you could say. I'm currently starting a bigger company, trying to find people to work with me to basically enable our customers with data and database on Kubernetes. And working together with a company of about 120 persons. So it's going to be huge. It's going to be awesome. But yeah, currently still employed by myself, basically. By the way, this logo was created by my son, my youngest son. I'm so proud of him that he could create such a beautiful logo. So just wanted to talk to that just a little bit as well. Maybe some people already know me, maybe some don't, which is fine. I have been in the database space since 2000, and I'm a cloud native enthusiast since 2015. Even before that, I was already into Docker and what can you do with it, looking into the technology and all that stuff. But the whole cloud native approach, that really struck me deep in 2015. I worked for DAE, which is the Dutch government for jail systems. I worked for bol.com, which is a Dutch huge company. You could compare it a little bit to Amazon, but Amazon is global and bol.com is mostly in the Netherlands. But they are technically very equipped as well. I have worked for EDB, Enterprise DB. And I had I did many cool things there. I started off as a consultant and then a solutions architect, which was basically what I loved to do most. But then I noticed that I wanted to bring the databases into the cloud native world. And they needed a product manager for that. So I did the product management stuff. And I worked together with the development team, even did a lot of development myself in Go on the operator and all that stuff. And so that was a really cool time. Then I worked for RIVM, which is a Dutch company, which is a Dutch organization, which is basically about healthcare. And they brought me in because they needed to do a lot of stuff with Corona. Everybody needed to do stuff with Corona, and they needed to do that as well. But that was also when I started as Mannem Solutions. Currently, I'm working for the Dutch government again, but this time for the Dutch tax office. And I'm also working for BMW. So as you can see, I'm really broad in projects that I've worked on. I'm a contributor since ever. I contributed a module to Ansible once, which is called PGHBA. I contributed to Stolon and to WallG, which is a high availability product and a backup product for Postgres. As I joined for the Dutch tax office, we did a lot of work on Bitbucket, and I did some contributions on the Bitbucket CLI as well. And there's a lot more stuff that I've contributed to. I also wrote a lot of tools myself, which are called out below: PGFGA, PGRoot 66. I think they're all written in Golang at the moment. I write a lot of software in Python, Golang, and recently I also started contributing in Rust, which I'm going to be talking about soon. And you might say I'm a dreamer. So I really feel that we should do everything open source, which is the way to move forward as a community. I really feel strongly about communities in general. And of course, Doc and the Postgres community in specific have a important place in my heart, you might say. Cool. As I was working for EDB, I also did a presentation which was called 60,000 TPS, but how many CPUs? Which was very closely related to some of the stuff that I'm trying to do over here. I also wrote a tool there, which was written in Go and in Rust, and I compared the two. I currently have rewritten it in Rust, and I'm going to talk to that in just a little bit. So I wanted to call that out specifically as well. So that's the introduction. So what's my mission? Well, 100% open source, both gov and private. I really feel for modern, so early adopter, everything that everybody's trying to do in 10 years. That's what I want to be aiming at. And data, well, ever since I started in IT, I specialized in data and databases specifically, but data in general as well. So, yeah. Cool. As I mentioned before, late December, I joined the Dutch government, worked together with some other guys on a special project where we wanted to introduce OpenShift for the Dutch tax office. They're huge on that front. And all of the stuff that I'm talking to is also part of that venture that we're going into. And one of the first challenges that we run into is what we call temporary access. I'm going to first explain the challenge. So we wanted to run databases. We wanted to run them on OpenShift, which is Kubernetes, you might say. And then you have a database and an app. And the database needs to connect to the app with a user, and that user needs to be authenticated. So the big challenge was, how do you do that? And I was working closely with a database team, but they really come from, let's just say, classical environments. And they wanted to stand up federated authentication using LDAP and all kinds of other stuff. And me and the architect, we pushed back on it. So why did we push back on it? Well, if you look at the CNCF. CNCF has a GitHub page where they basically keep the definition of cloud native. And this text that you see over here is basically what CNCF says about what cloud native is. And you see all of these keywords like scalable, modern, dynamic, and loosely coupled, and all of that stuff. And so to say, LDAP is not very cloud native. So what do I mean with that? There's not really declarative APIs. It's not really loosely coupled. It's not really resilient. It's not really scalable. It's not really observable. So basically, there's a lot of this stuff over here that you cannot meet up with properly if you move to LDAP. And there's newer stuff, right? So like OAuth and all of that stuff. But we were looking at other approaches as well. And we sort of felt that naturally you would drift from cloud native. You would look for authentication methods where you could use LDAP, federated authentication, and things like that. But the main thing that we were trying to fix there was the way that humans connect. I mean, for humans, it's very easy and well put to basically use a federated authentication system. And then you could have, let's just say 100 or 1,000 DBAs or developers, and they're all in that LDAP, registered in that LDAP with their username and passwords and all that stuff. But if you think about the natural way that the application is used, is that basically you only want the app to connect. Basically, you want to create your OpenShift project, you want to create your database, you want to create your app, and then basically you want users to authenticate against the app. And you want the app to, of course, authenticate against the database, but you don't want every user using the app to be authenticated specifically against the database for many reasons, actually. So, so that was one thing. The other thing was, of course, you might still want humans to connect, but we could find other ways for that as well. So we decided to focus on the way that apps connect. And as we were looking at Cloud Native Postgres, they have this natural option, which is doing client certificates. And I'm a huge fan of client certificates myself. You could basically, everybody use it already in tons of different ways. And then we call it MTLS. So MTLS is server-side certificate, but also client-side certificate. And there's a lot of security related subjects there, but also it is very much, it's decoupled. Like you can just have this without LDAP being up, and it still would be working properly. It just requires certificates to be provided at Postgres for you to check that the client certificate is valid, and all of the stuff. All of the rest is basically client-side configuration, which is the way that you want it. It's very specific for a project. So if those client certificates would be leaked, you cannot use them with any other of the other projects. So there's much going on here, which is awesome. And so we wanted to have an option for DBAs to log into Postgres as well. And then we decided that client certificates is also there as well, because it's short-lived. You could have a client certificate which is only valid for a day or for a couple of hours. And so if you have a issue and you have somebody trying to investigate that issue, he could have a very short-lived certificate, only valid for 4 hours, investigating the issue, and then fixing the issue. Basically, you want that by deploying a new version of the application. So you don't want the DBA to do anything with it at all anyhow. So this really felt like a very secure option. And it also felt like very, how do you say it? Scalable, very loosely coupled, very resilient, and all of that stuff. So we were thinking about how would we implement that, and we've come up with a solution. Basically, you could say the Cloud Native PG operator would just create your Postgres cluster, and you could create a secondary object within OpenShift, which is called a break the glass object. And basically, it would just be a placeholder to create users in the database and to create certificate requests for Cert Manager. And then you could have Cert Manager basically creating all of the certificates, including the certificates for the users that they use for logging in. Now, we are planning to build this. Firstly, it's going to be built as a separate project, but I've already talked to the guys of the CMPG operator and also to the guys of the StackRes operator, and they might include it in their projects so that you could just use it natively from Postgres as well if you like. So yeah, I just wanted to call this out. This was one of the things that we ran into. And yeah, as a short summary of it, if you look at it from the first angle and the way that you usually approach it in classical database environments, you might go in a totally different route than if you look at it from the cloud native perspective. So yeah, that was one of the things that I wanted to point out. Yeah, and as you can see, the break the glass option is very cloud native. So it's scalable, it's modern, it's loosely coupled, it's observable. Yeah, it isn't problematic to have high impact changes frequently and all that stuff. So so it fits perfectly well. Yeah, and this sort of is my, you could say, my adagio. I feel that that's the way that the modern integrator should be operating. Like, we should be looking at problem cases, we should be looking at resolutions, and we should be building them and also be open sourcing them. I see a lot of people doing that, and that is basically how we got to OpenShift, how we got to Postgres, and how we got to a lot of those other cool tools that are out there. And that's the path forward. And from here on, it's just gonna help you if you choose that path yourself as well. So that's strongly, part of Mannem Solutions' mission as well. Okay. So the second challenge that we ran into was database performance. We were, as I mentioned, we were running Cloud Native PG on OpenShift, and it was running on premise, and it was running on Ceph. And we wanted to test, like, how fast can it go? So we did some performance tests. We used PG Bench for the insiders, and I was hoping for huge in performance, like over 9,000. But in reality, it was only 1,300 TPS, transactions per second, which is not that awesome. And the way that you could look at it is that you see that we have 62 milliseconds of latency, which is huge. It's a lot of latency for every call, which is also why we have this short TPS. Currently, we have a DBA that is rerunning all of those tests constantly, and he even did a little bit more than 1,300. But this is basically what we could push out of the system. So what's going on? So I did some more tests. First of all, I separated this for write-ahead log from the data files, which is what you should do anyways, and Cloud Native PG supports it. We also added memory, we added CPU and all that stuff. And we just to rule out that this is a storage performance problem, we also looked at what would happen if you have faster performing storage. We did it the wrong way. I just want to call it out. Don't ever do this yourself, but it was an easy way to just see what would happen if we would have better performing storage. And so yeah, first for separate wall. So you could see that we ran a little bit faster, but it wasn't really that much faster. So separating out wall did not really help the case. We tried increasing the resources. So we tried it with more CPU and more gigabytes of RAM. It wasn't a huge increase either. I see a question in the chat, by the way. Let me just see. Yes, so Mark, the way that I see it, so the question from Mark is, this would require all of the dependent web apps to leverage client certificates and administrators to manage groups and RBAC inside of Postgres. Yes-ish. So yeah, your web app should be able to leverage client certificates, which is, it's just a little bit of extra configuration, and all of the clients support it. So it's not difficult to set it up. And if you have set it up once, then probably you know how to set it up for all of your web apps. But yeah, it is something that you need to configure extra correctly. And the biggest challenge is that you need to make sure that you get access to the client certificates, which would be there in a secret, but you still need to mount it in the pod and all of that stuff. So that's totally true. You also mentioned that you need to manage groups and RBAC inside of Postgres. Well, that is something that you probably want to do. And if you want to do it, then you also need to do it for client certificates, and you also need to do it if you want to do it with LDAP. It's sort of a separate thing. I would advise to do it, but it is something that you just do within the database schema. So as you create your database schema, you create your tables and all that stuff, and you could also create your whole RBAC on top of that. The cool thing is that with client certificates, you could have separate groups so you could have users entering as not as a user, but with a connection to a group, and then you could have those groups have permissions, which is cool, right? So you could have a DBA group, you could have an app group, you could have a reporting group, which only has read-only access on things like that. But definitely, you need to set it up inside Postgres correctly. Yeah. Okay. No, that's fine, Mark. Just interrupt as much as you want. That's fine. Okay. So we also increased resources, and that didn't really do the trick either. And then I did the one thing that you should never do, basically. I tested with fsync. Fsync is off. So never do anything with fsync is off. What happens is basically you could corrupt your database big time. So whenever you have database corruption, you reach out to community and they find out that you have fsync is off, then basically they will not help you. Basically, they say, dump the data, create a new database and load the data. And it's the only way to get it proper again. Now, in my case, what I basically did was I bypassed the whole fsyncing stuff just to see if it had a performance improvement, because I wanted to know if fsync was basically where we got the latency from, and if improving fsync and latency would also improve TPS. And definitely it did, right? So the latency was dropped by half, and the transactions per second was doubled. So basically you could say faster storage would help, obviously. Let me see. I have one more question in the chat. Let me just see. Yeah, thanks you. Cool. Okay. Cool. So now, is 1300? Is it awesome or is it poor, or what are we actually looking at? I wanted to compare some. Of course, I know already, but I just wanted to compare it, just to show some numbers to other guys as well. So I ran Cloud Native PG on K8s as well. And there you could see that we ran 1200 TPS. But if we increased the vCores, then you could see that we also ran higher TPS. So here, adding more resources like vCores and RAM basically also helped. Now, how does it help? We needed to run, I think you could see it. No, that's not true, actually, no. So the reason why this helped is that we could have a stronger, basically the storage was better attached, was having more resources attached to it and more buffering and all that stuff. So a friend of mine is working inside of Microsoft, and he mentioned to me that I should redo these tests, because they definitely fix something in the way that storage is attached, and it does really help for the Azure Postgres one. But I also want to do it for K8s again. So I will redo these tests, but at least more resources does help, and it didn't on our environment. So for REVM, I also created PG Village. And PG Village is basically VM deployment. And you can just easily deploy it on Azure. So I wanted Postgres running on Azure VMs, and I wanted to test with that. And what you can see is that if you just use normal VMs on Azure and you run Postgres against it, you could see that separating out the wall really does help, right? So the latency drops by half, TPS increases, doubles. And you could even see that if we increase the machines, we get it also helps for on cloud environments. If you increase the machine size, you also get higher throughput for your storage. You could see that we even halved latency again, and we doubled the TPS again as well. So we could even do more transactions per second on VMs. And this basically scales all the way up. So if we would increase to even larger VMs, we could even get bigger TPSs. So this is the way that you want to have it, I guess. Okay. Of course, I also tested with Azure Postgres, which is basically Postgres running on Azure as a service. We used burstable VMs there. It's just crazy expensive to do anything else, which is weird. But anyways, but you could see that we get nice numbers there as well. And this is basically what we got out of our system. This is what's basically the top of it, 1337. So now the big question is, why is on-premise not over 9,000? Why can't we scale it? Why is it bottlenecked somewhere? Where is the bottleneck? And the way that I see it is that if you look at databases, most of your data is basically in memory. So the database, if you run a query, the database fetches data pages from storage. It fetches it into the file system, and the file system basically offers it in as a memory block to the database engine. And then you could change it a gazillion times, but it always is a change in memory. Now, what also happens is that whenever you have decided that this is the way that you want your data, you could persist it, which is what you call a commit. So you could use the whole transaction mechanism, and if you use the commit of the transaction, that's basically when the write ahead log, which is where all of your changes are recorded, basically is persisted on disk, and there is a round trip there. So the file system basically says to the storage, I want all of these files up until this point, at least, I want them on disk. And just tell me if it is on disk. So you get this round trip where you get this fsync. The file system does an fsync, and it goes to the storage, and the storage says, yes, it's on disk. And this whole round trip thing, this is where basically where it starts to become, where it starts to become interesting. So let's just zoom a little bit into it. First a side story. The way that I look at these things is always that I see data as, you could say it as a warehouse, right? This is where all your data is stored, and fetching the data takes a lot of time. But it isn't really in line. It's not like every box that comes in here ends up on these shelves anyways. Usually it stays on these bands over here. And some of those packages are really directly distributed from this truck into this truck. But sometimes you get stuff that should be stored for a longer period of time. And then you get all of this stuff. So it's not fast, but you can store a lot of data over there. That's basically the way the databases store their data as well. They store it on disk. Now this is a totally different from how they store the apply log. So the apply log is basically where they keep all of the transactions, all of the changes that are applied to the data. They keep a record of it. And the apply log is not like a storage distribution center at all. It is more like an assembly line. So you get all of these transactions that are coming over like one big train of transactions. And so this has an interesting thing that it is mostly write. It is also updated inline. And it's stream based as well. So if you want to improve your TPS, usually what you should do is just make sure that your apply log can go faster, so that there's a bigger lane over here, or that it goes faster through this whole lane, if you can do something like that. So that's the way that I always look at it. Okay, I see another question in the chat, by the way. Exactly. I think Azure Boost is what this friend of mine was talking about as well. Let's. So I created a test program, and I want to do a lot of tests with this test program, and I want to look at a lot of different architectures, and I want to do a presentation on that maybe somewhere next year, I guess. I'm definitely going to have a look at Azure Boost. Thanks for that comment, Igor. Cool. All right. So so this is as deep as I'm going. I'm sure. I'm sorry for going as technically deep, but it's just the way that my brain works. All right. So we have this database, and you have this data which is constantly changed in memory. Sometimes it's checkpointed in the background, but it's not in line. for the performance. And then you have this apply log, and this apply log is currently written into, and every time when you push a commit, then you have this fsync. Now, if you look at this piece over here, where you have the communication between the file system and the storage, basically, if you look at classic, you could have, you would basically have a file system, which is a kernel driver. Then it goes like something like SCSI bus or something like that, and it writes it to a disk, right? So this is very directly coupled, and with that also extremely fast, you could say. You could have a faster bus, and then you would go faster. Or you could have a faster disk, or even memory cache or things like that. So yeah, then you would bring down latency. But basically, this is very fast. Now, what do we have with Ceph? With Ceph, we have this file system and this kernel driver as well. But then we have the TCP network. And through the TCP network, you go to different nodes. And every node is running software, which is basically the Ceph software, which writes through the driver, through the kernel. It was a file system on top of it, but basically that it's now included into Ceph. It writes directly to the driver. And then it still goes through the SCSI and to the SSD. But two main things are different. So first of all, you have this TCP network, this node software, and an extra call on the driver in kernel somewhere. But next to that, you also have it on two different nodes. This depends, of course, how you have stored your data. You could have it on 2 nodes, 3 nodes, 1 node. You could also have it on 1 node. And this has a huge impact on the latency. Now, if your latency is is brought back, is not that performant, then you would immediately see it in the TPS as well. So that's basically what we are looking at. Now, within the Dutch government, I brought this forward. I also mentioned like we could look into other options for storage and we could improve it. And so I wanted to spend some extra time on it. But we figured like, yeah, well, probably 1300 usually probably is enough. Now, why is it enough? So in classical environments, you would have your app, which is a huge monolithic application, big thing, which is running on a huge database as well. It's hammering the database constantly. It's requesting a lot of data to be crunched, all that stuff. And this one big monolith is sort of in line directly with the performance of this app. But what we are running microservices. And within microservices, we could have many different paths. And you could say that Ceph has the bandwidth. It doesn't have the TPS. It doesn't have it has slow latencies, but it does have the bandwidth. It can do a lot in parallel. And this is where it gets really strong as well. So if you have all of your microservices running together, every one of them gets 1300 TPS. Now, what if you need a microservice that requires more than 1300 TPS? Well, of course, we still need to look into other options. But for now, we felt like, yeah, probably this is not going to be a huge problem in the near future. Let me have another look at the chat. OpenEBS. No, I sort of use the cloud as, how do you say it? Because OpenEBS is, I guess, is a cloud thing, right? It's probably an AWS thing, I guess. We use the cloud as a comparison. We want to run our databases on premise. I did look at other solutions like Portworx and Longhorn and things like that. I want to test with that actually. But no, we haven't looked into OpenEBS at the moment. Ah, okay. I will definitely have a look at it. Is it something like Portworx then, I guess? Because with Portworx and with Longhorn, you basically get directly attached storage, and then there is a syncing mechanism in between it. But you also write directly to your local volumes. Ah, that's cool. Okay, cool. I will have a look at OpenEBS as well. Thanks for the suggestion. Yeah, cool. Okay. Nice, thanks. Okay, cool. Yeah. We will have a look at it as well. Thanks. So anyway, I still wanted to fix it. So I talked to our architect. And I felt like there's much stuff we could do. We could do storage with faster editing performance. We could even use directly write to the disk, the virtual disk. We are testing with that at the moment. Once we have it available, we're going to test with it with Postgres, our Postgres deployment as well. But this is one option, and I mentioned the other options as well, right? So, and there's OpenEBS. So we're definitely going to have a look at it if we can improve it. But I talked to the architect, and basically he said, well, 1300 TPS is fine. Don't worry about it. So I don't know how much cycles I can put into it, which is fine as well. Okay. Yeah, this is the main thing, the main story of this talk. But I wanted to talk about some other things as well. Oh yeah. So as I was going through this, I wrote this. I was looking at it and I noticed that I was constantly running pgbench. And why was I constantly running pgbench? I wanted to run pgbench with 20 clients and with 40 clients and with 60 clients. I wanted to know the whole spectrum. And why do I want to know the whole spectrum? Well, first of all, some applications can only run with a few clients parallel. But second of all, I also wanted to know the optimum, and there is an optimum here. There is a point in time where your latency increases and your TPS doesn't really increase anymore. So there is sort of a Goldilocks zone, you could say. And I want to know that Goldilocks zone for our architecture and for most of the architectures as well. So I was running pgbench, but I was running multiple versions, multiple configurations of pgbench, and I sort of got tired of it. So I wrote a tool. It is called PG_TPS Optimize. You can find it over here on the Mannem Solutions GitHub site. It is out there. It is, yeah. I think it's just the release 0. whatever. But I am now at the point in time where I want to basically start using PG_TPS Optimizer against multiple configurations, just to see how those configurations compare to each other. And basically what you get out of it is an image like this. So we use the Fibonacci curve. So we have 1, 2, 3, 5, 8. So it's sort of a logarithmic increase in the number of clients. And then you get the number of latency and TPS. And you also get this awesome graph over here, which is the TPS divided by the latency. And this is where you can see that, there's a sort of a Goldilocks zone. So you get a sort of a table output. I just wanted to call it out. And yeah, let's continue with some other things that we ran into. Well, I talked about Bitbucket CLI already. I think it's important for companies to enable themselves. And if you have companies that want to run, organizations that want to run Bitbucket, which is fine, but then just at least enable yourself that you can just go as fast as you could go. And for me, that was basically adding some small additions to Bitbucket CLI. We run our own compiled version of it, but it's really enabling us. We could even use it in containers and do stuff from our pipelines with Bitbucket and all that stuff. So it's awesome. We have a thing where we work with Project Quota. And basically, currently, we have rebuilt this. We currently have built our own internal operator, which is basically doing everything with projects and quotas the way that we want it. I'm on the verge of open sourcing it. I guess in a few months, it's going to be open sourced out there. It's very opinionated. It's very Dutch tax office like. But it's just cool how easy it was for us to create our own operator and enable ourselves with that as well. So I think this is just the way to go. Interesting thing, by the way, we created another image for this whole Project Quota thing. And it only has 2 criticals and 16 high we build an image with OC and TKN and all kinds of other tools in there. And we used that image before, but it was huge and it had a lot of vulnerabilities. And now we create our own Golang image, and it's tiny and it also has 0 vulnerabilities. So that's awesome as well. Which is one other reason for me, I would say, just build yourself. But just don't do all of this bash stuff with all kinds of other tools. I would go for this option. Anyway, then we have the break the glass functionality, what we already talked about. I wrote a very small Golang program to basically, I call it a pipeline runner. You can just set params from the environment. It will read the pipeline definition and it will create a pipeline, start it. You could do sort of the same with OC and TKN and all kinds of other tools, but then you get this whole thing again, right? So smaller image, 0 vulnerabilities. And we are thinking about building our own image pooler as well. There's a lot of projects out there that do stuff with image pooling, but I think we will do something ourselves as well. So, okay. So let's just say that you're an organization and you want to do stuff like this as well. Maybe you are in some kind of government agency, but you also want to do bleeding edge stuff. My first tip would be just think cloud native. So the way that we approached it, and I mentioned it before, just think cloud native. If you ever come up with a solution, just think, does it match up with cloud native with all of these keywords? If it doesn't, rethink it probably. So that's my first gesture. The second one is enable yourself. So we use cloud native PG not because well, there's more options there, but it was open source. We could just run it. We could do a POC with it. It's not being said that it's going to be the Postgres option for the Dutch tax office. Currently, we're still looking into options what we want to run. But we could run with open source and we could run a POC with it. So I would just say, do that yourself as well. Just start running databases on Kubernetes and get some experience with it. And as you go, you will know what you need. And once you know what you need, then you could look into what tool best fits, and you could acquire support for it and all that stuff. GPL, yeah, GPL is funny. Everybody hates GPL for some reason, but the Linux kernel is GPL, so I just don't understand. Most of my software, by the way, is GPL, which basically means if you want to sell it, then you need to upstream your changes as well, which is the only thing that I'm looking for, actually. So if you want to use my software, you want to sell it, fine. But if you change it, just give me your changes as well, and then we could make the upstream project better as well, which is the only thing. Cool. Okay. So this is basically where I laid out everything. Dutch government is embracing cloud native. It's beyond the Dutch tax office, by the way. It's also RIVM is also looking into it. DGI is also looking into it. A lot of other Dutch governments are looking into it as well. Currently, we're on the verge of embracing cloud native. Data on cloud native, you could say. Yeah, if you want to run cloud native on OpenShift Ceph, it's very doable. Well, this is what we got out of the system. Maybe you could go a little bit faster, but it's not going to be a big game changer, I guess. But look at other storage options if you need more. I mean, there's tons of other options there. And you could do it already, right, with 13 TPS. So, and the key takeaways, think cloud native. Don't fear to build your own. Just open your source. Just share it with the whole world, right? It's the way forward. And decide on expectations that you have and investments that you are willing to put into. Like, for us, 1300 seems to be fine. Then just don't put any more effort into it, right? If it's fine, just do with that. But upfront, just decide what are your expectations. How fast do you want to go? All right.
Thanks so much, Sebastiaan. That was really interesting. It's great to hear from your experience, and yeah, it's always great to hear like use cases and case studies like this. So that's fantastic stuff. Thank you so much. We've got a lot to learn there, and that's it. See you all next time. Thank you so much for joining, and thank you, Sebastiaan, for sharing with us. It's been great. Bye.